Good morning, 11th students. In chemistry part 2, lesson number 8, redox reaction, part 7 of the chapter redox reaction, we are starting our next topic with fourth type, disproportions reactions. Yesterday I taught you the types of redox reactions 8.3.1, that is first we described combination reaction, then decomposition reaction. Third one, displacement reaction. In displacement reaction, I taught you metal displacement and non-metal displacement. Now the most important reaction, that is disproportional reactions. Okay. Now what is that? See, disproportional reactions are a special type of redox reactions. Okay, special type of reactions in the fourth category. In this reaction, an element in one oxidation state is simultaneously oxidized and reduced. Okay, one element simultaneously, the same element is going to oxidized and reduced. This is the special character. One of the reacting substances in a disproportion reactions always contain an element that can exist in at least 3 oxidation states. Okay, minimum 3 oxidation states. The element in the form of reacting substances is an intermediate oxidation state. That is, and both higher and lower oxidation states of that element are formed in the reactions. I will teach you with one example. We will start that the decomposition of hydrogen peroxide H2O2 is a familiar example of this reaction. Okay, where oxygen experience disproportionate. How? See, this is hydrogen peroxide. Okay, I am writing hydrogen peroxide is going to decompose into H2O and oxygen. H2O is liquid, oxygen is. This equation is calling 8.45. Now how this element of oxygen in H2O2, here the oxygen of peroxide H2O2 which is present is in -1 state is converted to 0 state in oxygen. How? See, H2O2 is equal to 0, 2 plus 1 plus 2 oxygen we are finding 2 1 2 plus 2 oxygen is equal to 0, 2 oxygen is equal to 0, 2 will go there. Okay, so 2 oxygen is 2 upon 2, so oxygen states is oxygen's oxidation state is not +1 but -1 because +2 will go there, so -2. Okay, so hydrogens, I am not talking about hydrogen, I am talking about oxygen only, -1. So oxygen of hydrogen peroxide's oxidation state is -1 in H2O2 from -1 to 0. Now oxygen, I am describing of oxygen and oxygen 0. Okay, now oxygen is here also in one compound, here oxygen here also and here also. The same element of the compound is oxidized and reduced. Okay, this is the speciality of disproportional reactions. So oxygen is -1 to 0. Okay, followed? In H2O2 from -1 to 0, H2O2 oxygen. Now and decrease to -2 oxidation state in H2O2 from -1 already -1, and in H2O oxygen's oxidation state I am showing you. H2O is equal to 0, 2 plus 1, oxygen is equal to 0, 2 plus O is equal to 0, O is equal to -2. So here +1 of hydrogen and -2. So here oxidation state is -1 from -1 to -2. So decrease, and here increase. In H2O2 from -1 to -2 in H2O. Followed? So decrease and increase. See here, oxygen to this oxygen increase, and from this to this decrease. So I am showing you with the help of a chart. See H2O2. Here we are talking about oxygen. Oxygen is going to convert into H2O, H2O and oxygen. Okay, this reaction again I am repeating. H2O plus, not balancing, I am just showing. So oxygen I kept here, this oxygen to this oxygen, okay, from -1 to 0, this oxygen and this oxygen, -1 to -2. So decrease, oxygen -1, -1 to 0, increase, and -1 to -2 decrease. Okay, so this is a very common example that H2O2, in H2O2 oxygen is going to increase and going to decrease simultaneously. So this is a special type where the same element of a compound is going to increase and decrease in oxidation state, is called disproportion reactions. Like that, similarly, phosphorus, sulfur, chlorine undergo disproportion in the alkali medium. Alkali medium means we are taking NaOH, but we will show only OH, that is of alkali. The examples for phosphorus reaction is 8.46, for sulfur 8.47, and for chlorine 8.48. I am showing you. See, P4 3OH, P4 H2O will undergo pH3 H2PO2. Like that you can do the practice. 8.46. The same element phosphorus from 0 to -3. Phosphorus 0 to +2. Okay. So only we are showing the oxidation state of phosphorus from 0 to -3, from 0 to +2. So one side decrease and one side increase. Like that sulfur 8, 12 OH in alkaline medium. So only we are taking OH ion. This one is sulfur H2O2. So from 0 to -2, from 0 to +2. Cl2 OH ion, chlorate ion, Cl ion. Okay. So chlorine from 0 to +1, from 0 to -1. To one side going to decrease and one side going to increase. Okay. This reaction is 8.48. Now, on the basis of reaction 8.48 for the chlorine, like chlorine, bromine, iodine follow same trend, but fluorine shows deviation. This behavior when it reacts with alkali. See, for the chlorine 2H chlorate ion, the reaction 8.48 describes the formation of household bleaching agents. Okay, chlorate ion. The hypochlorite ion formed in the reaction oxidizes the color bearing strains of the substance to colorless compounds. Okay, bleaching agent, no? The color, if you want to remove from that colored compound, that is called the bleaching agent. It is of interest to mention here that whereas bromine and iodine, see, like chlorine, bromine and iodine follow same trend, but fluorine shows deviation from the behavior when it reacts with alkali. The reaction that take place in the case of fluorine is as follow: 2F2 OH ion, F ion, OF2 H2O. This reaction is 8.49. So it is to be noted that among halogens, due to more electronegative does not show a disproportion tendency, it cannot exhibit positive oxidation states. Though this is the limitations of fluorine, why fluorine doesn't behave like chlorine, bromine and iodine. Due to high electronegativity, they are having the limitations because it doesn't show the electropositive nature. Now I am solving your problem 8.5. Which of the following species do not show disproportion reactions and why? These four species. Also write reactions for each of the species. Okay, among the oxo ions, these are called oxo ions. ClO minus 1, ClO2 minus 2 minus 1, ClO3 minus 1, ClO4 minus 1. See, you have to see how you can say among the oxo ions of chloride listed above, ClO4 minus 1, this one does not disproportionate, this is not a disproportion reaction. These are, why? Because you have to see the oxidation state. It is having a maximum oxidation state. See, ClO4 minus 1 is equal to 0, minus 1, Cl plus 4 minus 2 is equal to minus 1, Cl minus 8 is equal to minus 1, Cl is equal to minus 1, 8 will go there. So its oxidation is plus 7. So the among the element who is having the highest oxidation state will not show a proportional reaction. In this way you have to show the reaction ClO minus 1 like that. Okay. Now our next problem 8.6. Problem 8.6. Suggest a scheme of classification of the following redox reactions. Scheme means you have to show the type of classification. 4 class I showed you. Again I am revising. I showed you combination, decomposition, displacement, and the last one this. So first one, N2 plus O2, you can see 2. So this is the example. In the reaction A, the compounds, first reaction, N2 plus O2. Among the 4 you can see, this is the example of combination because nitrogen and oxygen are going to combine. So this is the example of combination reaction. This is combination reaction. Second one is lead nitrate, PbNO3 twice is going to convert into PbO plus NO2 plus oxygen. So this is the example of decomposition because this compound is going to decompose into different compounds. So second one is the example of decomposition. Okay. Third one, sodium hydride plus H2O gives NaOH plus H2. So you can see Na here H plus OH ion. So OH ion is coming here and H ion is going to there. So this is the example of displacement, metal displacement. Okay. Fourth one, this is the example of disproportion reactions because you will see the oxidation state of NO2 here and here. Okay. So NO2 is converting into these two states. So in one state it is going to oxidize and one state it is going to reduce. Okay. Now our last problem you have to solve by yourself only. Problem 8.7. Why do the following, if you are not following, why do the following reactants proceeds differently? Okay. This you have to solve by your own. If you are not following, I will teach you. Tomorrow in our next lecture, I will show you balancing of redox reaction. That is most important topic of this lesson. So please students, I beg you that you see all the rules and you follow whole of the lesson. Then you can be able to balance the redox reaction. Otherwise you can't able. Balancing of redox reaction I will teach you in 2 methods. Okay students.